Okay, for those of you at home, we are starting indicator 14 today, and so you will need to copy down here in a second. I'll show all the steps needed to solve these, and then each one of these examples, copy those down in your notes. We will have a note check later in the week. All right, so for all of you in class, flip to the back of your paper. And to save time, I wrote these out for you so that you didn't have to copy them down and write them out, but I still want to go over them. They will make more sense once we actually work through a few problems, but I still want to talk through a little bit of each one, okay? So step one, make sure at least one equation is solved for y, and this will be your clue, and this will make sense when we go through it. You are then going to put parentheses around your clue. Then you're going to put parentheses around the y in the other equation. And this part is really important. If you think about an extension cord, right? For it to work, you got to plug one into the wall and one end into your lamp, right? And that's the way you get the power, is to use everything. Think about an extension cord. If you plug the one end into the other end, it's not going to get you anywhere, right? You're not going to get any power from that. It's the same way with these. You have to plug one into the other. If you plug it into itself, it's going to be like an extension cord with the two ends plugged in together. It's not going to get you anywhere, okay? Then you are going to substitute the clue into the parentheses in the other equation. You're going to solve for y. You're going to plug the value of y into any of the equations that you have, and you're going to solve for x, and then you're going to write your answer as an xy coordinate, okay? And like I said, this will make more sense as we go through it, and we will go through several examples and kind of go through these steps over and over again, so it'll make some more sense, okay? All right, so example number one there. The first step was make sure at least one equation is solved for y. This will be your clue. Well, boom, they're both solved for y. So step one is done, okay? Because they're both solved for y, it doesn't matter which one you pick to be your clue. So I'm just going to pick the top one to be my clue. And so the next step was to make this a 1 so it's not quite so fat. There we go. The next step was to put parentheses around your clue. So I'm going to call this first one my clue. So I'm putting parentheses around my clue. Now the reason we're doing this is because if I just asked you to solve this system of equations and you've got unknown x's and unknown y's, with two unknowns, can you solve an equation? You can't. Right? You can't solve an equation with two unknowns. So what we're going to do is, if this is a system of equations, that means that the one point where they cross, the one xy coordinate where they cross, is going to be the same point. So the y's are going to match and the x's are going to match. So if we can take one equation as a clue, plug it into the second equation, then it will allow us to solve for the one variable, and we'll get an answer for our system. So step one was to make sure one is set to y. We already had that. We put a parenthesis around what we're calling our clue, okay? And we're using that top equation as our clue. Now it says put parentheses around the y in the other equation. So I'm going to come to the other equation, and I'm going to put parentheses where there's a y. And then it says substitute your clue into the parentheses of the other equation. So this one right here is our other equation. So I'm going to take my clue from the first equation and I'm going to plug it into the parentheses of the other equation. So I've got x plus 8 equals, right? That's plugging the clue from the first into the spot where the y was in the second. And then I'll just keep writing out the equation. And by doing this, I haven't changed anything because I know that y equals x plus 8. So in the other equation, in place of y, if I use x plus 8, now everything is in terms of x. Now I only have one variable. Can I solve for x? Okay, I can. All I have to do is get all my x's on one side, all my numbers on the other. So I'll start out by subtracting 5x and subtracting 5x. And that gives me negative 4x plus 8 equals 12. And then I have to subtract 8 from both sides. And I get negative 4x equals, well, 12 minus 8 is 4. And then I divide by negative 4, and I divide by negative 4, and I get x equals negative 1. Now remember the answer to a system of equations, and I'm going to just pause here for a second. I'm going to jump over to another screen. I'm going to show you just kind of a recap of yesterday. Okay, and if you want, at the very top of your paper, kind of in that upper margin, if you want to remind yourself of this, it would not be a bad idea, okay? When you have a system of equation, there's three possible answers. We talked about this yesterday. There's the one solution that's all the way over on the left, and when you have one solution, it's where they cross, it's where they intersect, and it's always expressed as an ordered pair. Or you have parallel lines that never ever touch, and it's no solution. Or you have two lines that actually are the same line and they forever ever touch, so it's infinity. Okay, so those are your three possibilities as far as an answer to a system of equations. So if let's go back to our notes now. If we take our system here that we're working with, well, we already know that x equals -1. We just found that out. And our answer has to either be an ordered pair, no solution, or infinite. Well, we've already got the x value, so we know it's going to be an ordered pair. So for my x value, I'm going to put a -1. And I don't know the y yet, but I at least know half my answer. Well, if I have, let me erase these arrows just so I can see what I'm doing here. If I have my x value, can I now find my y? I can. I can take what I know about x, plug it into my clue, which is y equals x plus 8. And in place of x, now I can put a -1. So now I'm using my clue again. So y equals, and in place of the x, I'm going to put a -1, -1 plus 8. And -1 plus 8 is 7. So my y value of my system of equations is 7. So this is my answer. So I'm solving my system of equations. And if I was to graph y equals x plus 8, and then y equals 5x plus 12. If I were to put those both on a graph, they would intersect at -1, 7. But the reason we use something like this is because we don't always have a graph available. And remember yesterday when I said even when you do have a graph available, you have to be so precise about drawing your lines and using your slope to really get good points, because if your line's just off a little bit, by the time you get to the other side of the graph, you could be 2 or 3 blocks away from where you're supposed to be. So even with a graph, it's hard to get an answer of the system of equations on a graph, let alone when you're not given a graph, there's no way to actually draw it to scale to get a real true answer of where they cross or what the solution is. So if you're not given a graph, then you have to do it mathematically rather than visibly by graphing them, okay? Now, I want to show you, it does not matter. You'll notice on your notes, it said for that last, or for the 6th step, plug the value of y into any of the equations and solve for x. Well, if I had chosen to plug it into this one, it would have worked just as well, right? Y equals 5 times x, which is -1, plus 12. Y equals -5 plus 12. Y equals 7. You would have gotten y equals 7 no matter which one you plugged into. And the reason is because since this is a solution to the system, it means it's the solution to both equations. So it's going to match no matter what, okay? I just picked x plus 8 because it was a little bit easier. And we'll talk about here in a little bit when it's even easier to pick certain ones, okay? All right, so number 2, step 1 is make sure that one of your equations is set to y. It already is, okay? Now, I want to show you something here. We're going to have an answer here that's an x and a y. This one happens to give you something. What is the y value here? Yeah, it's 4. They give it to you. You don't even have to find it. So half the work here. So you already know y equals 4, so make that your clue, okay? That's the smartest thing to do here. Make 4 your clue, which means you go into the other equation and you put parentheses where there's a y, and then you plug that 4 in because we know that y equals 4. So we would have 4 equals -2x plus 14. Dylan, you got all this written down? And then we've got to subtract 14 and subtract 14. And 4 minus 14, when the signs don't match, you subtract and take the sign of the bigger, so -10. And then you divide by -2 across the board, and you get x equals 5. So there's my x value. And there's my answer to my system. So when one of them is either y equals 4 or even x equals something, if they give you one of them, run with it. It's half the work. Okay, they've given you half your answer. You just have to plug it in and find your other half. Okay? Any questions on the first two? All right, so it says make sure one of your equations is solved for y. Here, one of them is solved for y, so that makes that one our clue, right? Because that's the one that is solved for y, that's the one that's our clue. So it says put parentheses around your clue, so I'm going to put parentheses around my clue. And then I'm going to go to the other equation, and I'm going to put parentheses around the y. And then I'm going to substitute in, right, my clue parentheses into the other equation where there was a y. So I get 14x minus 2. Use your parentheses here. You have to because you're going to be distributing. Plug in my clue of 7x in place of the y equals negative 6. Now again, remember my answer here. It's going to be an ordered pair. So PEMDAS says I have to distribute before I can do any combining or adding or anything. So I'm going to do I'm going to do 14x and then distribute. Negative 2 times 7 is negative 14x equals negative 6. What's 14x minus 14x? Remember, these guys are together on the same side of the equation, so I don't have to add or subtract or move anything. I just have to combine them. What's 14x minus 14x? 0 equals negative 6. What happened? No solution. My x's completely disappeared, and I got a false statement, right? 0 does not equal negative 6. So this would be an example of no solution, because remember, when we have a system of equations, our three possible answers are an ordered pair, no solution, or infinite. And in this case, because all of our variables completely disappeared, we have no x and y that they have in common. We don't have an ordered pair. We have no solution. Okay? Any question there? All right. So for this one, right, we do have to do a little work at the beginning, because step one is make sure at least one equation is solved for y. Well, neither one of them are solved for y. Looking at it, and it doesn't matter, looking at it, which one do you think is going to be easier to solve for y? The first one or the second one? Yeah, the first one, because y is already kind of by itself as far as you don't have a variable attached to it. So it just saves you a little bit of work. Okay, so I'm going to make this one my clue, this top one. So I'm going to add 6x and add 6x. And that gives me y equals 6x plus 5. Now that that one is set equal to y, that one is my clue. So I'm going to put parentheses around it. Okay. And I'm going to go into the other equation and put parentheses where there's a y. And then I'm going to substitute my clue into the other equation inside the parentheses. So that gives me 3x plus 2 parentheses. This is where I insert my clue, 6x plus 5, and then continue writing out that equation. So it's equals negative 20. Now this is a little bit more work because you have to distribute that 2 into the whole parentheses, right? This is why I said using your parentheses is really important here, because I have to distribute that 2 into everything inside the parentheses. So 3x, 2 times 6x is 12x, 2 times 5 is 10, and then equals negative 20. Now, remember, when they're on the same team, you just combine them, right? You don't have to add and subtract and move them around. All you have to do is combine them. So if you look at the left side of this equation here, we've got 3x plus 12x. Oops, that was supposed to be red. There we go. We've got 3x plus 12x. Well, they're together on the same side of the equation. So we're not going to subtract or add or move anything. We're just going to combine them. 3x and 12x is 15x. And then this plus 10, we're going to minus 10 and minus 10 because we do have to move that to the other side of the equation. So we get 15x equals negative 20, negative 10 is negative 30. Negative 20, go deeper, 10 more, negative 30. And then I'm going to divide by 15 and divide by 15, and I get x equals negative 2. My answer, again, right, is going to be an ordered pair. I have half my answer. Now, you'll notice again it says plug the value of y into any of the equations and solve for x. I have the two original equations, and then I have the equation that I kind of wiggled around and got y equals. Of those three, which one do you think is the easiest one to find the value of y for? It's the one I made, right? The one that says y equals, and the reason is because y is already by itself. So I'm going to use that equation. I'm going to use my clue equation as the one that I'm going to plug into. So I've got y equals 6 parentheses. I'm going to plug my x value that I know, right? That's my new information that I have, plus 5. So I'm using the y equals 6x plus 5. And it'll work if you use any of them. I could use the negative 6x plus y equals 5. I could use that other one. It doesn't matter. You're going to get the same answer. This one is just the easiest of the three to use. So y equals 6 times negative 2 is negative 12 plus 5. Negative 12 plus 5 is negative 7. So my y value is negative 7, and there's my answer. And as long as you follow the 7 steps that I have on the back of your sheet every time, you're always going to get there, okay? All right. Of these two, which one is the easier, the first or the second? Which one is easier to get y by itself? The second one, just because there's nothing to divide off the y, so it's just a little bit easier, all right? So I'm going to use my second one here, and I'm going to add 2x and add 2x, and that gives me y equals 2x minus 7. Now that I have one set to y equals, that becomes my clue. I go to the other equation and put parentheses around the y. And now I'm going to substitute my clue about y into the other equation for y. So negative 4x plus 2 parentheses. My clue about y, which is that it's 2x minus 7, equals negative 14. Okay, I'm writing that whole top equation. Negative 4x plus 2y equals negative 14, but in place of the y, I'm going to put my clue. Now, again, right, PEMDAS says I have got to distribute first. So I'm going to write my negative 4x, distribute 2 times 2x is positive 4x. 2 times negative 7 is negative 14 equals negative 14. I've got x's on the same side of the equation, so I need to combine them, right? These two are on the same team. I just need to combine them. What's negative 4x plus 4x? Yeah, they cancel each other out. And I'm left with negative 14 equals negative 14. All my variables are gone, which means this is a special case. Is negative 14 equal negative 14? Is that a true statement or a false statement? It's true, so the answer is that it's infinite. And that's one of my 3 options. One ordered pair, no solution, or infinite. The no solution and the infinite only happen when your x's and your y's disappear. Any question on that one? Is it easier having the notes with them? Okay, good. That's good to know. All right, number 6. I got to pick one to make. Okay, now thinking through that, and we can do that, but if I make the top one, kind of think through it. I'm going to have to subtract x and subtract x, which is going to give me 5y equals negative x plus 0. And then when I divide by 5, I'm going to have a fraction here. And I don't like fractions. So I'm not going to do that one. I tried it. I started it. I saw that it's going to give me a fraction. I don't like it. So I'm going to try the other one. Let's see if the other one will be easier. So let's add 4. And this is sometimes you have to just work them both and just see if one of them is easier than the other. Sometimes it jumps right out. Sometimes it doesn't. So plus 4x gives me 4y equals 4x plus 0. I divide by 4, and divide by 4, and I get y equals 1x and then anything divided with 0 on top is 0. So basically y equals x, right? You can even simplify that down to where there's not so many unneeded numbers and just say that y equals x. So that becomes our clue, right? You always put parentheses around the clue. Go back into the other equation, which I've already used this one, right? I made that one my clue, so that can't be the one I now plug into. So I now go to the other equation and I put parentheses around the y. And now I rewrite this equation right here. X plus 5. I'm plugging in this right here. So x equals 0, right? X plus 5y equals 0. And I've got my clue about y. X plus 5x equals 0. X plus 5x is 6x equals 0. But again, right, anything with 0 on top is what? Okay, I want to point this out because this is where I see probably the most mistakes year after year. This is not a special case. A lot of people get to x equals 0 and say, oh, it's no solution. My x didn't disappear. My x actually equals 0. So in my ordered pair, in the x spot, I would put a 0. Okay? My x did not go away, so it is not a special case. The only time it's a special case is if my x were to cancel out and go away to 0, not if my x equals 0. It's okay for x to equal 0. That's not a special case. Well, I also know that y equals x. So if x is 0, what's y? Yeah, it's also 0. So my point where they cross is 0, 0, and that's okay. That's not a special case. It just means that if you graph both of these equations, they're going to crisscross right at the origin. Okay, and that's not a problem. All right, flip over because I want to show you this one on the back, and I will tell you, you can make yourself a note here. If you will listen to what I'm saying here, it will make numbers 7, 11, and 12 on your homework easier. Okay? All right, so let's think through if we were to get y by itself here. So if I get y by itself here, I would minus x and minus x. So that would give me negative 6y equals negative x plus 19. And when I divide by negative 6, do I want to mess with that? Nope, don't like that one. So let's look at the other one. I subtract 4x and I subtract 4x, and that leaves me negative 5y equals negative 4x plus 19. And then I divide by negative 5. Do I like that? Nope, don't like that one either. Both of those give me really ugly fractions. There is actually, you can do it. If you just love working with fractions and you just want to challenge yourself, you go to town. But look at that pretty little x sitting there all by itself, okay? What if, using the same principles that we've already learned, what if we get x by itself? So what if I add 6y and I add 6y, okay? And that gives me x equals 6y plus 19. Do I have a clue about x? I do. I can go into the other equation, and since this is a clue about x, what would I put my parentheses around? The x, right? Not the y this time because my clue's different. But it's the same principle. I got x by itself. I now have a clue about x. I go into the other equation. I put parentheses around the x. And now let's plug in what we know. We know that x is 6y plus 19. That's my clue. Minus 5y equals 19. Now I do it all the same, right? I have to distribute. And when I distribute, I get 24y. What's 4 times 19? What is it? 76. I love it. Thank you. Okay, I took a positive times a positive, so it's positive 76 minus 5y equals 19. Now, I've got this 24y and this negative 5y, and they're together on the same side of the equation, so I'm just going to combine them, right? So 24y minus 5y is 19y. Plus 76 equals 19. And then I'm going to subtract 76 from both sides. And I get 19y equals what? Minus 19 equals 57. Negative 57, right? Because negative 76 is the negative number here is bigger. So my answer is negative 57. And then when I divide by 19 and I divide by 19, I get y equals 3. Positive 3 or negative 3? Negative 3. So my answer, right? I don't know my x yet, but I know my y is negative 3. But that's okay. I found my y first. It doesn't hurt anything. Now, what am I going to plug back in to find my x? I would use this one, my clue, right? I know that x equals 6 times y, and I now know that y is negative 3 plus 19. 6 times 3 is negative 18 plus 19, so x equals 1. So x equals 1. It's still the same process. It's just if it's easier to get that x by itself, do it that way and find your y first. Okay? It doesn't change anything. If you did this whole hairy problem with all those ugly fractions we were talking about, you still would have gotten x equals 1 and y equals negative 3. It would have just been more difficult to do. Okay? And keeping that in mind, like I said, that'll make 7, 11, and 12 easier on your homework, and it'll make you not have to deal with ugly fractions. There was something real quick I wanted to tell you, and I don't remember what it was now. I thought of it earlier when I was doing something, and I thought I'd wait. Never wait. I should have just interrupted myself. All right, I think that's it. All right, for those of you at home, hit the load button and complete your assignment on Cami, and email me if you have any questions.